Hey there, science fans! Today we're diving into the world of solutions. What are solutions? They're everywhere. A solution is simply a special type of mixture where one substance dissolves evenly into another. Think about making Kool-Aid. You start with water, the solvent. That's the substance that does the dissolving. Then you add the Kool-Aid powder, the solute. The solute is the substance that gets dissolved. When you mix them, the Kool-Aid powder seems to disappear. But it's still there. It's just broken down into tiny particles spread evenly throughout the water. That's what makes a solution homogeneous. It's the same throughout. Now you can't just mix anything and call it a solution. The solute has to dissolve completely in the solvent. If you see chunks floating around, that's not a solution. Solutions come in different forms. We can classify them based on the states of matter of the solute and solvent. First up, we have gaseous solutions. Ever breathed air? Congratulations, you've experienced a gaseous solution. Air is a mixture of gases like nitrogen and oxygen. Next, we have liquid solutions. These are the most common. Salt water is a classic example. Solid salt dissolves in liquid water. Finally, there are solid solutions. These are a bit less common. A good example is brass. Brass is a mixture of copper and zinc, both in their solid forms. Imagine making 2 pitchers of Kool-Aid. One uses 1 packet of Kool-Aid mix, while the other uses 3. Which one will have a stronger flavor? You got it, the one with more Kool-Aid mix. That's because it has a higher concentration of solute. Concentration tells us how much solute is dissolved in a given amount of solution. We can express concentration in many ways. One way is mass percentage. This tells us the mass of solute per 100 grams of solution. Another way is molarity. Molarity tells us the number of moles of solute per liter of solution. A mole is just a unit chemists use to measure really large numbers of particles. Understanding concentration is important in many areas of life. For example, pharmacists need to make sure medicines have the right concentration to be effective and safe. Have you ever tried to mix oil and water? They just don't want to mix. That's because oil isn't soluble in water. Solubility is the maximum amount of solute that can dissolve in a given amount of solvent at a specific temperature. Several factors affect solubility. Temperature is a big one. Think about making hot chocolate. You can dissolve more sugar in hot milk than in cold milk. Another factor is pressure. This is especially important for gases. Higher pressure usually means more gas can dissolve in a liquid. Finally, the nature of the solute and solvent matters. A helpful saying is like dissolves like. Polar substances tend to dissolve well in other polar substances. Nonpolar substances do the same. Oil is nonpolar while water is polar, which explains why they don't mix. Section 5. Vapor pressure solutions like to stay liquid. Ever noticed how a puddle of water seems to disappear after a while? That's because some of the water molecules escape into the air as water vapor. Every liquid has a vapor pressure. It's the pressure exerted by the vapor of a liquid when it's in equilibrium with the liquid phase. Adding a solute to a liquid actually lowers its vapor pressure. Why? The solute particles get in the way of the solvent molecules trying to escape into the gas phase. This lowering of vapor pressure is one of the colligative properties of solutions, which we'll talk more about later. Section 6. Raoult's Law, Predicting Vapor Pressure. Raoult's Law gives us a handy way to predict the vapor pressure of a solution. But there's a catch. It only works for ideal solutions. Don't worry, we'll get to those later. Raoult's Law states that the vapor pressure of a component in an ideal solution is equal to the vapor pressure of the pure component multiplied by its mole fraction in the solution. The mole fraction is simply the ratio of the number of moles of one component to the total number of moles in the solution. Raoult's Law helps us understand how the properties of solutions depend on the amounts of each component present. Section 7. Ideal versus non-ideal solutions. Do they follow the rules? Remember how we said Raoult's Law only works for ideal solutions? Well, not all solutions are ideal. Ideal solutions are like the perfect students who always follow the rules. In these solutions, the interactions between the solute and solvent molecules are very similar to the interactions within the pure substances. Non-ideal solutions are a bit more rebellious. The interactions between the different types of molecules aren't as well behaved, so they don't always follow Raoult's Law perfectly. Most real-world solutions are non-ideal to some extent. But that's okay. We have ways to account for those deviations. Section 8, colligative properties. When more stuff means different behavior. Colligative properties are like the cool kids in school. They only care about how many friends they have, not who those friends are. In other words, they depend on the concentration of solute particles, not on the identity of the solute. One cool colligative property is boiling point elevation. Adding a solute to a solvent raises its boiling point. That's why we add salt to water when cooking pasta. It makes the water boil at a higher temperature. Another one is freezing point depression. Adding salt to icy roads takes advantage of this property. The salt dissolves in the ice, lowering its freezing point and causing it to melt. Osmotic pressure is another important colligative property. It's the pressure needed to prevent the flow of solvent across a semi-permeable membrane. It plays a vital role in biological systems, such as regulating water movement in and out of cells. Section 9. Conclusion. Solutions are everywhere. From the air we breathe to the oceans we swim in, solutions are all around us. Understanding how solutions work is essential in many different fields, from chemistry and biology to medicine and engineering. We've learned about different types of solutions, how to measure their concentration, and how factors like temperature and pressure affect solubility. We've also explored Raoult's law, ideal and non-ideal solutions, and the fascinating world of colligative properties. Remember, science is all about exploring the world around us and asking questions. So keep experimenting, stay curious, and never stop learning. And next time you make Kool-Aid, you can impress your friends with your knowledge of solutions.